Hello learners, welcome back to our YouTube channel, Roboarmy. Today, we are going to make an exciting project car parking system. So here we have a single lane road for our parking area. To detect the entry of a car in the parking area, we will use an IR sensor here. To open and close the parking gate, we require one servo motor. To show the number of available slots in the parking area, we will be using one 7-segment display. And here Arduino is our controller. When the car enters, this sensor detects the presence of the car and sends a signal to the Arduino. In the code, we have to define the total number of parking slots. For example, here we have 4 slots. Then the Arduino checks the possibilities, slots available or not. If slots are available, servo will rotate to open the gate. Once the car passes through IR sensor 2, the servo will rotate back and close the door. And the slot count will decrease by 1 in the 7-segment display. When a car exits there, we need an IR sensor to detect the car and send a signal to the Arduino. Again, the servo will rotate to open the gate. And the slot count will be increased by 1 in the display. If all slots are full, the display will show 0 and the gate remains closed. Before we move further, let's take a quick look at what we need more for this project. One 220 ohm resistor to limit the current and prevent damage to the LED. One breadboard. One USB cable to upload code. A double battery holder with a DC power jack and switch. 2 lithium-ion cells. Some jumper wires. Now, let's go through the circuit connections step by step. Firstly, take the Arduino board and breadboard. Connect the 5 volts pin from the Arduino to the positive power rail on the breadboard. And connect the GND pin from the Arduino to the negative power rail on the breadboard. Now take one IR sensor. Insert male to female jumper wires in it and connect its VCC to the positive power rail on the breadboard and GND to the negative power rail. Then connect its out pin to digital pin 11 on the Arduino. Take the second IR sensor and similarly connect its VCC and GND pins to the breadboard as done earlier. Then connect its out pin to digital pin 12 on the Arduino. Now take the servo motor and connect male to male jumper wires in it. Connect the brown wire to the negative power rail on the breadboard. Connect its red wire to the positive power rail. Then connect the orange wire to digital pin 10 on the Arduino. Now place the 7-segment display on the breadboard. Connect the common anode pin, that is the center pin, on either side of the display to the positive power rail on the breadboard via a resistor. Now connect the other pins of the 7-segment display to the corresponding digital pins on the Arduino using jumper wires as shown in the circuit diagram. Segment A pin to pin 2 on the Arduino. Segment B to pin 3. Segment C to pin 4. Segment D to pin 5. Segment E to pin 6. Segment F to pin 9 on the Arduino. And segment G to pin 8. Again, verify your connections according to this circuit diagram. With our circuit set up, it's time to write some code. Download the code and library files by using the link provided in the description below. Now open the file if you've already downloaded the Arduino IDE, otherwise download the Arduino IDE first. Here you can see first, we have included the servo library, which helps us control the servo motor. Next, we created an instance of the servo class and defined the pins for our IR sensors, the number of parking slots, and some flags to manage the sensor's state. Then we have defined the pins for each segment of the 7-segment display and set constants for turning the segments on and off. In the setup function, we set the pin modes for the IR sensors and the 7-segment display segments. We also attached the servo motor to pin 10 and set its initial position to 100 degrees, closed position. In the loop function, we continuously check the state of the IR sensors to manage the car entry and exit logic. When IR sensor 1 detects a car means output is low and the flag is not set, we check if there are available slots. If so, we decrement the slot count, update the display, and set the flag to indicate the sensor was triggered. When IR sensor 2 detects a car means output is low and the flag is not set, we increment the slot count, update the display, and set the flag to indicate the sensor was triggered. Once both sensors have been triggered, we wait for a second to allow the car to pass, then close the gate and reset the flags. Here, we have several functions to control the 7-segment display. Each function turns on the appropriate segments to display numbers from 0 to 9. The counter function takes a number and calls the appropriate display function to show that number on the display. And that's it. You can also change the parameters as you wish. Now upload the code by following some instructions. Connect the Arduino UNO to your computer using a USB cable. Then select Port and Board in the same menu and select Arduino UNO. Now upload the code by clicking the Upload button. You can see the sketch is first verified by the compiler and then uploaded to the Arduino. Now install this circuit in the structure like this. And power the Arduino by using your battery pack via DC power jack. Here's how our smart parking system works. When a car arrives, the IR sensor 1 detects the car and signals the Arduino. If there are available slots, the servo motor rotates to open the gate. The number of available slots displayed on the display decreases by 1. And when a car leaves, the IR sensor 2 detects the car and signals the Arduino. The servo motor rotates to open the gate for the car to exit. The number of available slots increases by 1, indicating a vacant slot. Hence, we've created a smart parking system that efficiently manages parking slots. Thanks for watching. If you enjoyed this video, be sure to give it a thumbs up and subscribe for more DIY projects and tech tutorials. Till then, keep learning.